Hi, it's Hailey McKinnon and Keith Watt Green in Period 4 talking about stoichiometry, mole-to-mole ratio, balancing equations, and grams to moles. First, what is stoichiometry? Stoichiometry is the study of quantitative relationships between the amounts of reactants used and the amounts of products formed by a chemical reaction. Stoichiometry is based on the law of conservation of mass. Things to remember when balancing equations. There are many things to remember when balancing chemical equations, but make sure when balancing equations you end up with the same amount of each type of atom on the reactants and product side. So basically you want them to cancel out, so it would be 2, 2, and 10, 10, and make sure they're the same on each side. So you would get 2, 5, and 2 on the top. The stoichiometry diagram is super handy to use when trying to do these equations. It will just make you remember how many T-charts you need. So you can start with either grams of initial substance or moles of initial substance, and you can end with either moles of final substance or grams of final substance. And as you can see on top of the arrows, it'll say what you need to do to get to each step. Grams to moles. Finding grams to moles is a 2 T-chart problem. So as you can see, you will need to use 3 of these boxes. You will need to use grams of initial substance, moles of initial substance, and moles of final substance. So you will have to find the molar mass and coefficient to get to these 3 steps. Examples of grams to moles. So as you can see, that is the example problem we will be using. And it'll say if 17.5 grams of H2 are used in the reaction, how many moles of SN would be made? So as you can see, we started with grams and we end with moles. And lucky for us, this equation was already given to us balanced. First, start with the information that is given to you, and 17.5 grams H2 is given to us, so you will put that on the top left of your T-chart. Second, look on the periodic table and find the molar mass of the element you are using. In this problem, it was 2.02 grams H2. So we will put that on the bottom right. Make sure it is diagonal to the H2 since they are the same substance and they're both grams. Third, we are trying to find what 1 mole equals to, so we will put that in our T-chart. So as you can see, I put 1 mole on the top right. Fourth, multiply the top, then divide the bottom. As you can see, it would be 17.5 grams H2 times 1 mole H2 divided by 2.02 grams H2. The answer we got for this T-chart would be 8.66 moles H2. Fifth, now that we have done the first T-chart, it is time to do the second T-chart. As you can see from past slides, you will need to do 2 T-charts. So, we will start with the answer from the previous T-chart, which was 8.66 moles H2, so we put that on the top left. Seventh, since we are trying to find how many moles of SN would be produced, we will look at the balanced equation to see how many moles there are. There was 1 mole of SN in our equation, so we will put that on the top right. Next, we will find how many moles of H2 there are in the equation, which is 2 moles H2. Make sure you put it diagonal with the other H2 since they are the same substance and SN is not the same as H2. Ninth, we will multiply the top, then divide the bottom like before. It should be 8.66 moles H2 times 1 mole SN, then divide it by 2 moles H2. The final answer should be 4.33 moles SN. Now take it to Keith to know mole-to-mole ratio.
Hi, this is Keith with mole-to-mole ratio. Finding mole-to-mole ratio is a 1 T-chart problem. Finding the mole-to-mole ratio by starting with the number of moles from the initial substance, putting the information into a T-chart, we will be able to find the amount of moles of the final substance. Examples of mole-to-mole. The example problem we will be using is 2 hydrogens plus 2 oxygens. If 24 moles of oxygen gas are used to make water, how many moles of hydrogen gas must be used? First, we will use the information given to us, which was 24 moles of oxygen. Second, we will see how many moles of oxygen are given in the equation. They gave us 2 moles of oxygen. Third, since the problem is asking for how many moles of hydrogen, We will see how many were given in the equation, which was 2 moles of hydrogen. Fourth, we will multiply the top and divide by the bottom, which will be 24 moles of oxygen times 2 moles of hydrogen, 2 moles of oxygen. The final answer should be 48 moles of hydrogen. Types of stoichiometry equations. Double displacement. Two ionic compounds react to make two new compounds. Single replacement. An element replaces another element in a compound. Synthesis. Two or more small parts come together to form a larger compound molecule. Decomposition. Larger molecules break down into two or more parts. Types of stoichiometry continue. Combustion must have these two compounds.